Question number 22. The car travels at a constant speed along a straight line PQ. A loudspeaker attached to the car emits sounds of constant frequency. A stationary observer is at point O. So observer is at this point over here. Okay. What is the observer here as the car moves towards P towards the Q? Okay, from P to Q as it moves, then what happens to it? Now, what happens is initially when the car is at this point P, now what is the distance? This is the distance over here. After 1 second, this is the distance over here. Then this is the distance. So as you see, the car starts moving from P to Q, the distance keeps on reducing, and here the distance is the least one. Okay, now we know that velocity is proportional to distance. Okay, so here when it comes over here, when it is at this point, what happens? The distance is much lesser as compared to this. Definitely velocity is lesser, which means, see, if the observer was here, okay, then I can definitely say that the frequency or the pitch keeps on increasing as the car moves towards it. But since the observer is at a farthest point, okay, so you cannot apply that rule, but instead you need to take the component of the velocity that's happening over here. So as a result of this, now what's happening here? So if you take the component here, if you take, this is your V over here, this is your angle theta, so this would be your V cos theta over here. Okay, now definitely this theta is smaller. When the car comes at this point, this will be your theta 2. Then what is the velocity here? This will be V cos theta 2. Theta 2 here is larger than theta 1. When theta 2 is larger than theta 1, cos theta 2 is less than cos theta 1. Which means what? The velocity at which this fellow receives here is much lesser. Velocity of the sound waves along this direction is much lesser. Okay, so the velocity of the source as seen from here is much lesser, not the sound wave. Thus we know that f dash is equal to f into c divided by c plus v source. That's what we have. So as a result of this, when this denominator increases, the frequency should decrease over here. Okay, remember this is the method how you need to do it. So therefore, a frequency less than f that decreases as the car moves from P to Q. No, this is incorrect. Okay, then a frequency that is a frequency less than f that increases. See, it does not increase. Frequency does not increase. Okay, a frequency more than f. Initially, frequency is more than f. Okay, that decreases. Now it starts decreasing as the car starts moving from P to Q. The frequency now keeps on decreasing over here. Okay, so the C is the right answer.